Most datasets that you will encounter in real world contain missing values, and the online shopping datasets that we are dealing with is no different. Let's start by importing the training and test data that we previously created, and I'm using the skimr package to look through the summary statistics of this dataset. This reveals a column called nMissing. This shows the number of missing value in each of the columns present in the dataset. Now, if you notice, these columns, administrative duration, informational and product related pages, have 11 rows missing. So I see some sort of a pattern arising from this. Let's use the mice package, the md.pattern function in mice package, to understand the pattern of missing values. Now this produces a graph like this. Here the blue cells represent non-missing values and the red cells represent missing values. So all these columns, these are the 8 columns that we saw previously. These columns have exactly 11 values missing. So 11 into 8, which is 88. Totally 88 cells are missing in this dataset. That's what it says. Another aspect, if you look at the training dataset, you will find negative values sprayed all over. These are also probably missing values. Whenever populating data for such datasets, it's a common practice to replace any missing values with -1 because we want the lowest number in such cases and we want to differentiate it from an actual zero that is present in the dataset. So when it comes to modeling, it is up to you to decide if you want to replace this -1s with missing values and then do an imputation to yourself, or you can keep it as -1 itself and then proceed with the regular modeling process as it is. If the accuracies are improving or degrading, based on that, you can make a decision on whether you want to replace these -1s or not. So for now, let's go ahead with keeping this -1 as it is. Let's revisit this later on. So there are various methods using which you can impute missing values. In Caret package, there are two very common methods. One is KNN impute, the other one is bag impute. Both of these methods try to predict the missing values based on values present in other columns in the dataset. KNN stands for the K nearest neighbors algorithm and bag stands for the bagging algorithm. I also want to show you how to implement missing value treatment using the mice package. This is not part of Caret package. Now, the way how you implement KNN and bag impute is using pre-process function. All you have to do is passing the training dataset and set method to KNN impute or bag impute for the respective methods. First, build the KNN missing value model. For KNN to work properly, the algorithm first centers each column. Centers means it subtracts the mean of the respective column from each and every row in the column. It has ignored 4 columns, set the value of k in k nearest neighbors as 5, and then it has scaled 14 columns. That's what it is doing before even building the k nearest neighbors model. Then once the model is built, use the predict function, pass the df train dataset itself as the new data, and impute it. For this to work, you need to use the RANN package, because the KNN algorithm that Caret uses comes from this particular package. Remember, Caret is only a wrapper for various algorithms implemented across packages in R. So for this one, it is RANN. Now, after doing the imputation, if you do an any NA function to check, there are no missing values in the dataset. Alternately, you can use bag impute, which has a very similar syntax for that. Only set the method as bag impute and all the values will be imputed. Here I am imputing both the training dataset as well as the testing dataset. If you notice, to learn the missing value imputation process, we are using only the training dataset. We are using that particular model to impute the testing dataset as well. So we have no knowledge of what is the data present in the testing dataset so far. So all the values have been imputed. Likewise, do an any NA check on DF test. There are no missing values. Let's export these two datasets. We have imputed it. Likewise, you can use the mice package. For this, you need to import the mice library. Only two steps. Call the mice function on dftrain dataset. Set the method as random forest. In this case, I'm using random forest. There are many other methods. You can check the help function of mice to check the various methods available. Here it has listed down all the various methods that you can use to impute the columns in your dataset. Certain methods can be used for only numeric values. Certain other methods can be used for categorical values as well. Once your mice model is built, you can use the complete function to fill in the missing values. Now, if you check any NA on this one, no missing value should be present. So that is how it is done. If you are wondering which method or algorithm you want to use for filling in the missing values, one approach to validate is you artificially introduce some missing values at random places in your dataset. You have to keep a note on where you are introducing the artificially missing values. Then use these algorithms to fill in those missing values. Then after filling it in, compare your filled in value against the actual value that was present. So whichever method gives you the most accurate result for filling in the missing values, you might want to use that particular method for the actual missing values present in your dataset. Now let's do a mini challenge. The challenge for this lesson is you have the training and testing dataset in the intermediate folder. Now use this dataset to replace all the minus ones with missing values first. Do the replacement of minus one with missing values and then impute all the missing values using k nearest neighbors algorithm. If you have access to your RStudio, try to give it a shot. Otherwise, I am going to show the answers anyway. So here's the solution. If you manage this, congratulations, you are making good progress.